So problem 415, I've drawn the free body diagram here. Identified what it is we're trying to solve for, P, and the reaction at C. Remember, Cx and Cy are just two components of C. I'm going to use this to introduce the concept. The next section in the textbook is 2 force members and 3 force members. This is a 3 force member, and I can see something about it, which would actually allow me to solve for another unknown. But let's just bang it out as easy as possible. Remember, Cx and Cy, I chose what direction to put them in. I don't spend a lot of time thinking about it. For this problem, yeah, it was really easy. I got one force going to the left. I must have a force going to the right for equilibrium. I've got one force going down. I must have one going up for equilibrium. But another problem, once we get out of like the single digit problem numbers, when we get to 440 and 460, they're going to be much more complicated, and I'm not going to know what's going to give me a positive answer. So I just pick a direction and I run. Right? You don't have to spend a long time thinking about what direction to put it in. But if I sum forces in the x, I'll go to the right positive. I'll have Cx going to the right. I look at Cy and I discard it because it's perpendicular. I look at P, I discard it because it's perpendicular. I look at the 1200 and say that's going to be minus 1200 newtons equals 0. I sum forces in the y direction equal to 0. I'll say up is positive. Cy is up. That arrow is not used. That arrow is not used. P is down. Minus P equals 0. I have 2 equations and 3 unknowns. I can solve the first equation for one of them, but I cannot solve the second equation. I will sum moments. Right. I have 2 arrows of unknown magnitude coming together at C, so I'll sum moments about C equals 0. I'll stay focused here mentally as I look at each of the other arrows in the free body diagram. These 2 will go away. The first one I see is the 1200. That's creating a counterclockwise moment. So I'll say 1200 newtons. And the perpendicular distance is given as 125. I will continue on. I've done that one. I've discarded those 2. I've got P. It's going in the other direction. P times 300 millimeters equals 0. I'll solve for P. I'll solve for Cy. I'll solve for Cx. Cx equals 1200 newtons. It's positive, therefore Cx is equal to 1200 newtons to the right. Had I gotten Cx was equal to negative 1200 newtons, I would write Cx is equal to 1200 to the left. Easy, easy peasy. P is equal to 1200 newtons times 125 millimeters. Bringing that over, divide by 300 millimeters. The millimeters cancel out. 12 over 3 is 4. 4 times 125 is 500. I'm left with 500 newtons. it's going down, as shown. Plug that in, Cy comes out to a positive 500 newtons. Also, it's going up, as shown. Questions about that problem? 500 down. If you need to solve for C, then it has two components, 500 and 1200. And it comes out to be 1300. 5, 12, 13 is another 3, 4, 5 sort of triangle. Comes out to be 1300. And inverse tangent, let me just write that. Inverse tangent of this is 500 over 1200. So inverse tangent of 5 over 12 is that angle 226.7. Just to make my son happy. So 2 3/4 members. 2/4 members are like cables, and I'll show some examples afterwards. But this is a 3/4 member. I could redraw it. I could redraw it. Never look at that while you draw it. P, and now if you identify that it's a 3/4 member, you know the direction of the third force. 3/4 members, the forces either need to be parallel, which is rare, or they need to be concentric, where they all come in to one place. They either need to be parallel, right? If I have this plate and I'm pulling on it with that and I'm pulling on it with that, my third force could be parallel and it could be in equilibrium. But if I have that same plate and I know that force is in that direction and I know that force is in that direction, they come together right there. And so the line of action of that force, say this was the unknown one, has to be concurrent at that point there. If it's not, then it's going to rotate. So 2/4 member just means if I have a member with one force on it, then the other force has to be equal but opposite, with only two forces acting on it. When I draw that example, it doesn't seem to make sense, but when I draw this example, right, maybe there's something going on here and I can't put the link directly between it. Maybe I got a rotating shaft here and I got to go around it and there's a force like that, right? They've got to be in line with each other. This is a 2/4 member. Has one force acting there, one force acting there. They've got to share the same line of action. They share the same line of action. That's a 2/4 member. This is a 3/4 member. And this is a 3/4 member. So from the geometry, 125, 50, I think it was. I gotta put that down. 75. And 300 because I knew the direction of P and the direction of the 1200, I knew that C, the reaction at C, had to hit that point. I knew that it was in that direction, and I wish I didn't have that 75 there. I'm going to draw it again over here, right? That has a run of 300. Look, run of 300 and a rise of 125, inverse tangent of 125 over 300 tells me that that force, 22.6 I think it was, tells me the direction of that force. So instead of having two unknowns here, right, and I want to remind me to show you the diagram and the reaction table again. It can either be two unknowns, like x and y component, or it can be two unknowns, magnitude and direction. But I know the direction of this one, so it's only one unknown. So this problem now is a problem with only two unknowns instead of three. It was three unknowns, and I solved for, I had to solve three equations for three unknowns. It wasn't very hard, but you know, when they do get hard, three equations for three unknowns, you'll appreciate, hey, if I had identified the three-fourths member, now I just have two equations and two unknowns to solve this one. Because now, right, remember, Cx is going to be 125 over the, Cx is going to be 300 over the hypotenuse, and Cy is going to be 125 over the hypotenuse times C. Right. Sum of forces in the x equals 0. I'll go to the right positive. How much of this is to the right? 300. This is C. I know the direction of it. I can do cosine 300 cosine 22.6 if you like, but it always is easier, both mathematically and envisioning it, if you get this 125 squared plus 300 squared equals square root 325. If you start seeing these triangles, 300 over 325 of C is to the right, minus 1200 equals 0. I'll instantly get C is equal to 1300. And sum of forces in the y equals 0. I'll go up positive. And so I have 125 over 325 of C going up, minus P equals 0. And I'll get P is equal to 125 over 325 times my 1300, or 500, I think it was. This one goes like that, whether you do 22.6 degrees or 125, 300. And this one is down. All right, questions on this one? What was I going to show